Hello students, let us deal with the last unit of Fundamentals of Electrical Engineering today. In this there are miscellaneous topics given to you in the last, since it is the last unit. Let us deal it one by one. The very first thing is basic layout of a distribution system. Okay, when I talk about a power system, you can see this is the single line diagram. Now the single line diagram, as you can see over here, it is starting with a generator point. Okay, so at generation, let us say 11 kV, 22 kV or 33 kV is the generation voltage. When it is transmitted at a higher voltage. So here you can see a transformer over there, and necessarily it's a step up transformer. Okay, then again you can see over here, after just before the load center, you can see over here it is step down. Okay, so there are two things, what is called as receiving station and substations. Okay, so the substations are in the load center, and the receiving station is just at the outskirts of the city. Okay, so this is actually the receiving station. Okay, and then you can see over here, these are the load centers. Okay, one more thing you have to just observe over here is, you can see over here it is a star marking. Okay, so you can see over here it's a star connected system, but over here you can see it is delta, again secondary of this transformer, step up transformer rather. You can see over here it's star connected. Okay, so just observe the connections. Okay, normally when we have distribution systems, we have to have a star connected system, because availability of neutral is really important, isn't it? Okay, one more thing I had told you when we dealt with three-phase circuits is the power consumed in three-phase circuits, when it is delta, it is thrice the star. Okay, so that is again one more reason why we use star connection in case of distribution systems. Okay, so this is just explanation regarding that single line diagram. That substation provides energy supply to the load center in which the line is located. The main function of the substation is to collect energy transmitted at high voltage coming from generating station and step it down to voltage to an appropriate value for a local distribution. Okay, gives facilities for switching. The substation is of two types. One is simple switching type, and another is converting stations. Okay, so that converts AC to DC and vice versa. Okay, the substation has an additional function also to provide points where safety devices can also be installed. Okay, when I talk about different wiring systems and wiring accessories, there are different wiring types. We'll be dealing one after the other. Let us talk about the very first one, is what is called as plate wiring. Okay, I suppose these things will be very clear with the diagram, so let us move further for the diagram. So you can see over here there are grooves like this. If at all it is single phase, 2 grooves, and if at all it is 3 phase, there are 3 grooves, right? Okay, so what is actually this is to guide those wires through. Okay, so these grooves are meant for guiding those wires. Of course, this particular wiring is actually the grooves can be of porcelain, wood or plastic. Okay, so these clips can be made up of these three. Normally this is actually, if you see, this is not very good looking. Okay, so this is not suitable for either residential or commercial use, but normally when it is temporary installations, for example, let us say a civil work is going on and the watchman's room is to be illuminated, so in that case it will be this particular wiring that will be used. Okay, another is casing keeping wiring. This is very old type. You can see such sort of wiring in very old houses, maybe your grandmother's or grandmother's houses. You can see this type of wiring where the wires are passing through wooden grooves. Okay, you can see over here the one is called as casing and the cap is called as caping. So casing, caping. Okay, and these both are made up of wooden. This is actually again ugly to look at. So one more thing is, just because it is wooden, it is prone to fire also. So it's cheap, but it is not used nowadays because of the not aesthetic look, and another is it is wooden, so it is prone to fire. Okay. The next one is what is called as batten wiring. I suppose this wiring again you might have seen over in some of the houses. You can see over here the wires are exposed actually, and at few intervals it is clipped by flexible clip, you can see over here. Okay, so again this is not so good to look at, but many a times it is preferred because it's a cheaper one. Okay. That you can still see these type of wirings used in some of the houses. Last one is what is called as conduit wiring. In conduit wiring there are two types. One is in which plastic or iron pipes are circulated throughout on the walls wherever you need a point, and the wires are run through those conduits. Okay, now if you just visualize this, will be looking like this. You can see over here, see like this. Okay, so in industries you can see like this. In commercial also premises you can see the wiring being done like this. But if at all you are thinking about residential wiring, these conduits actually are inside the walls. Okay, so maybe a thing that you must have seen because this is the most preferred one nowadays by builders. So one of the most positive point of these particular concealed wiring, concealed means the conduits are when inside the walls. Okay, so one of the positive point of this concealed wiring is it is very good to look at, very nice. You can directly see the point on the board, you can directly see the fan, but you never know from where the wire is running. Okay, but another negative point of it is very difficult to find out, to trace the fault actually. Okay, again better appearance, no risk of fire, no risk of damage. So it's really good. Only one thing is it's very expensive. Yes, it's expensive. And another thing is if you want to have any future expansions, for example, let us say now in my hall I need one more fan. So in that case it is very difficult because you have to just dig up the wall and again rewire it, and again you have to paint and do the civil construction also. So that is why it is normally very cumbersome for future expansion also. Okay, and this is what I talked about concealed wiring. Okay, yes. When I talk about wiring accessories, the very first thing should come into your mind is what are the materials, different materials used. When I say materials, it will be conducting materials, insulating materials, semiconductor materials. Okay. So conducting materials, normally copper is the best one, but economically speaking, aluminum gives it a better option, isn't it? Yes, you must have seen such type of cables, right? Such type of wires. Okay. Yes. Insulating materials means the cladding of these wires is either by rubbers or by plastic or by fiber. Okay. Many a times there is a cloth layer also on it, cotton layer. Okay. So these are the different accessories. You must have seen when you open an iron, you can see mica sheet over there. Okay, so these are different actually insulating materials. Okay. Now when I talk about accessories, wiring accessories, you can visualize these many things. Okay, you can see over here the different buttons, the different switches, the different MCBs, the pendant holders, etc., etc., etc. Okay, so let us deal one by one. Let me talk about first switch. Now when I talk about switch, there can be three types of switches. One is called as one-way switch. Now this one-way switch is the one which we normally use for our lighting purpose. So one is defined as on position and one is defined as off position, right? So you can see over here the picture like this. Okay, so this is on position, and if you press over here it is called as off position. These are also called as piano buttons. Okay. Two-way switch is the one which we use normally for staircase wiring. That means the same suppose staircase lamp I want to operate while going up, I turn it on, and after reaching upstairs I want to turn it off. Okay, so the same application downstairs you can see in the button, it is used as two-way switch. Okay, so you can see over here there are two poles over here, but here there are three poles. Okay, here it is defined as on position and off position. Here it is cannot be defined which one is on position and which one is off position. Okay, so that is a two-way switch. And the last one is intermediate switch. This again is used when we have to utilize an application from more than two locations. Okay, so that is why it is called as intermediate switch. The last one is flush switch. Actually, this is just an aesthetic one. It is not of use in it is just for decorative purpose. Okay, and next is bed switch. Again, these are the bed switch is normally not on the switchboard, but it is very much near to the bed, and normally flexible wires are used for that. Okay. Okay, next is what is called as pendant holder. Now let us move to the second accessory, that is holder. You must have seen this pendant holder while using Diwali lightings, or the light you have in Diwali in front of your front doors. Okay, so this is normally used for temporary things. Okay, temporary lightings. So that is pendant holder. Okay, you have to just insert your wire from this, and this is where you insert a lamp. Okay, that's it. The second one is what is baton holder. You can see this used on your walls for lamps. Okay, so where you use your CFL or incandescent lamp, etc. Okay, so this is what that baton holder is. Okay, so this is a permanent one, and this is a temporary one. Okay, the third one is ceiling rose. You can see this wherever there is a ceiling fan. The ceiling fan's input wire is coming out of the ceiling rose. Okay, so that is why it is called a ceiling rose. Okay, it's always there on the ceiling. That is why it is ceiling rose. Okay. The next one is socket. Again, this accessory you are very much acquainted with, because whatever appliance you will be using, you'll have to have that appliance's pin inserted in this socket. Okay, you can see over here the hole over here, what is called as for earthing, is greater in area of cross section if you compare to this live and neutrals. Okay, now why is it so is we want to ensure the safety of the operator. So even if the live neutral is connected or not, you want to make sure that the earthing is connected. Okay, so this is how the appliance is grounded. Okay, earthing is done through this. Okay, so if at all there are any kind of faults in your appliance, and let us say a fault current is flowing through the appliance, you do not want that fault current to flow through the operator, whoever it may be, your mother, you yourself, your father, whoever it is. So it should be saved. He or she should be saved from the electric shock. So that is why this earthing connection is there. Okay. You can see over here is there are live and neutral, two live and neutral given over here. This is one live and neutral, and this is another live and neutral. So when these three are used, this is lesser current application, and when these outer three are used, this is higher current application. So you can see over here, if at all it is refrigerator or AC, this outermost ones are used, isn't it? So just see the current rating that is given on the pin of your AC or the pin of your refrigerator, and just correlate it with the pin of your iron or mixer. Okay, and see what is the current rating given on it. Okay. Yes, the next one is what is MCB. These are actually the very old ones. These are made up of porcelain. These are porcelain fuses. You can see these in the society meters where everybody's meter is kept over there. You can see such type of fuses over there. Okay, ceramics ones, porcelain ones. And this is the one which we call it as MCB. This is normally there in our houses. So if at all there is any kind of fault occurring in any of the devices, this trips. Okay, so the problem of these fuses, where if at all the wire melts because of the fault current, you have to again get another wire of the same rating and then rewire it and then use it. Okay, over here it is just tripped off. So trip off, that means see, normally the on position is this and off position is this. In case of MCB, it is on position like this and off position like this. Okay, so why this difference is there is that it should be easy for tripping it off. So gravity will help it to help it in that direction. So normally this is what is on position and this is what is off position. So exactly opposite to the normal buttons, right? Okay, so this is how that MCB looks. Okay, these are the switches I just talked about. Okay, ICB switches also you call it as. Okay, ironclad double pole or ironclad triple pole. Okay, yes, these are different accessories which we use for our electrical wiring systems. Now let us move ahead to what is called as earthing. I think a few minutes earlier I talked about grounding or earthing. So grounding is same as what is earthing. So a wire is taken from the installations to the ground, so that if at all any fault occurs, the fault current instead of flowing through the operator's body will go directly to the ground. So that is why this provision is always made, and this is what is called as earthing. There are different types how this earthing is done. So let us move to those types. You can go through this bit later. Yes, I also talked about this necessity of earthing. So what are the different types of earthing? One is what is called as plate earthing. So there is a plate you can see over here like this, and this plate is grounded. Okay, yes, and another is what is called as pipe earthing. Okay, so there is a pipe which is inserted in the ground. Okay, so there are different norms of both these civil constructions. You can see, you can just go through. Okay, so how much deep it should be and what is inserted in it and all. Okay, so just go through this. It's all descriptive treatment only. Okay, so this is rod earthing systems. Okay, a rod is inserted. Now let me switch over to what are different lamps. Okay, incandescent lamp is the one you normally use in your homes. That is 40 watt, 60 watt bulbs, isn't it? Okay, so this looks like this, and normally its light is yellow one. Okay, of course this is based on the principle of heat energy. So you can see over here there is a filament over here, and if at all when the current is passed through it glows, and that is why the bulb glows, right? And if at all it is in on position, you cannot just take it out with your plain naked hands. You have to have either a cloth or a glove in your hand to take it out, because that is based on the principle of heat. Okay, so that is the tungsten filament which is used. Okay, the next one is what is called as fluorescent lamp. Okay, this is your fluorescent tube rather the one we use normally. Okay, so you can just go through the different technicalities in it. What is field inside, what is the reaction inside, what is the voltage given, okay, and what is the circuit. Okay, so when any descriptive question is asked to you, you will have to draw the circuit like this, and you have to elaborate on the working principle of it. Okay, so this is how it goes. You can just read it out. The next one is sodium vapor lamp. Sodium vapor lamp is normally used in the street lightings. Okay, but there are particular norms, like how much should be the height of the pole, because there are many things that are emitted from this which are not good for your health. So that is why it is mounted at a particular height, not lesser than that. Okay, you can again see the things construction wise also. You can go through the description. Next is what is called as metal halide. When I talked about metal halide, there can be, yes, you can see over here the circuit. Okay, so when it is asked about any of the lamps, you'll have to draw the circuit and you'll have to elaborate on the working principle. Okay, CFL is the one we normally use at our homes. The very first positive thing is it emits white light. Secondly, just because it is not on the based on the heating effect, so you can directly, even if it is on, you can just take it out from your plain hands without any gloves or without any cloth in your hand. Okay, because it won't be warm, it won't be heated. Okay, it looks also good because it emits white light. but the problem over here is to just discard when it is outdated, okay, because it has some harmful things in it which are not good for nature. Okay, you can go through the working principle, you can go through the construction also. And yes, the next one is LED. These are actually the ones we normally prefer now. May it be your tube lights, may it be your bulbs. Normally we go for LEDs now because the very first thing is it's lesser power consumption. So normally if a normal fluorescent tube light consumes 40 watts, you can see if at all it is a LED fluorescent tube, its consumption is almost half of it, 18 watts, 20 watts, like that, despite its illumination is quite good. Okay, rather it is more illuminating than your normal fluorescent tubes. Okay, so this was about LED. You can again go through the descriptions. Okay, the last one is how you read a residential bill. Okay, so whoever engineer you are, you should be able to read your residential bill as well as whatever is your industry, wherever you work, the bill of that particular industry. Okay, so before I just discuss about this, let us talk about what are the different factors that govern the billing. Okay, the very first thing is what is called as tariff category. What do you mean by tariff category is, see, you cannot measure everybody on the same scale, like industry, commercial things and residential things on the same scale, right? I remember, I think 10 years ago there was a big chaos in Mumbai, that the malls people had an objection why they should be charged with the same rate as industry or commercial. Okay, so they were charged with commercial because you can see in the malls those elevators continuously on, the lightings are continuously on. So you can measure on the line that many of the things are just for the show off over there and not as necessity. Okay, so why it should be the necessary things should be counted on the same with the same scale as the lavish ones, isn't it? So that is why there are different categories, and these categories will decide, like 1 unit of electricity will be sold at what rate. Okay, now this 1 unit to be sold at what rate is what is called as tariff. Okay, so the unit of this is what is called as tariff. Okay, so the tariff for industrial company is different, for commercial it is different, and for residential it is different. Okay, you can imagine that it is least for residential, a bit higher for commercial, and still higher for industrial. Okay, yes, again to have one more distinction over here is what is called as LT and HT. So when it is for 400 volts 3-phase supply given, it is high tension, and when it is 230 volt single phase supply, it is what is called as low tension. Okay, so normally when we talk about residential, it is always low tension, and when we talk about industry or we talk about small industries, even need this 3-phase supply. Okay, yes, so let us talk about the things. Like the very first thing we talked about is the bill will depend on which category you belong to. Okay, the next one is this is connected load. So when this connected load means, let us say it's a residential home, and you have to just predict like what are the different points, and that way the load is calculated. Okay, so this is actually pre-calculated. So when you get a sanction of it, the state electricity board sanctions this connected load. Okay, so you should not exceed that connected load, otherwise there is a problem, isn't it? Yes, the next one is electricity duty. Now what do you mean by electricity duty? The moment I say duty, you can also say it in terms of tax. Few of the states in India impose tax on electrical consumption. So again it is on the total bill. So percentage of on it. Okay, so less you consume, lesser will be the tax, and more you consume, more will be the tax. So in a way it is to restrict the consumption of electricity, isn't it? Yes. The next one is units consumed. Okay, so units consumed, like there are slabs, different slabs given. So up to 100 it is this much rupee per unit of electricity, and this 1 unit of electricity is actually 1 kilowatt hour. Okay, so 1 kilowatt hour energy is charged up to a certain rate for let us say 100 units. Then from 100 to 500 it will be again a bit higher one, and then again beyond 500 it will be highest one. Okay, so that is why again this is to just have a restriction on the consumption, isn't it? So those are the units consumed, and these are the units consumed. Normally you can see on your bill also. So as per the units consumed you are charged, right? The next one is tariff structure. So this you can see over here. In the tariff structure you can have, see, the units consumed, if 0 to 100 the tariff is 3.05. This is fuel adjustment charge. Now you might wonder what is this fuel adjustment charge. Let me just elaborate on this. See, when we are when it is a rainy season, the hydroelectric power plants are on, right? But when it is not rainy season, there are so many norms that water should be first available for drinking, then it should be available for remaining uses, then it should be available for etc., etc. So the last priority is electricity generation. Okay, so if all the needs are fulfilled, then only we can utilize the water for hydroelectric power generation. Okay, so thermal electricity generation, hydroelectric power generation, there are different things which are involved. Like if at all it is nuclear power plant, the raw material which is needed is different. Okay, so the coal rates are also fluctuating. So to just get adjustment for that, this is what is called as fuel adjustment charge. Okay, yes. So you can just go through this. Of course, this is different for the different states, right? You can go through your different a particular state's bill, and you can see this. This is normally at the back of your bill. Okay, back side of the bill. Yes. Next one is what is called as fuel surcharge. Now, if at all there are scarcity of the power and you have to utilize more fuel, in that case, to compensate for that, this is what is called as fuel surcharge. Okay, so that is in excess to the normal one. When I talk about the different charges, one is what is called as fixed charge. So this depends on the type of connection and connected load. So it's a fixed amount charged monthly on an electricity bill. Okay, so this is how the bill billing is done. You can go through your bill and just correlate whatever terms we had just discussed. Okay, thanks for watching. If at all you have any kind of queries, feel free to ask. Thank you.